Okay, so here's a quick video on solving equations with fractions. This is commonly requested for help because fractions are, typically a little bit more intricate to work with until you get used to them. So here is how I recommend that you deal with fractions when solving first-degree equations like this. All right. Now, if you have fractions, they make arithmetic a little bit more challenging. Right, we're used to problems that look like something like this. 2x plus 1 equals 5. It's like we've got that all day. That's no problem. So this method will turn an equation into something that looks like this, and then we can solve it from there. All right. If not exactly that, something close to that. So the idea is if I've got some stuff equals some stuff, and it's a bit ugly on either one or both sides, if I multiply it by some number to make it some nicer stuff, if I do that to both sides, hopefully I'll have nicer stuff equals nicer stuff. Okay? So this is exactly the goal behind this. So I've got some stuff on the left over here, some stuff on the right. It's not nice stuff. I want to make it nicer stuff. How do we do that? What do we multiply it by to make it nicer stuff? Well, whatever number I would have to multiply it by to destroy the fractions, right? And how do we destroy fractions? Well, we destroy them by having a multiple on top of what the bottom is. So over here, you're going to need to multiply by something on the top that is a multiple of both 2 and 3. Okay, so multiple of 2 and 3. A quick way to get that would be to multiply them together and get 6. But since we're doing this across the whole board, we need to include all of the fractions denominators. We want to blow them all away. So how you blow them all away is choosing a multiple, multiply by the number 2 times 3 times 5. That will guarantee that all of them get canceled, right? Because each of them at least has one thing they can cancel with. So 2 times 3 times 5 is 30. And so there's ways to do this more efficiently, but it doesn't really matter. This method will always work, okay? So 2 times 3 times 5 is 30. This will guarantee that each of these things cancel. And so this is the nicer number. This is what we multiply both sides by to make it nicer stuff. So let's see why that happens. Well, when I distribute through a 30, let's start on the left. 30 times y over 2, 30y over 2, plus 30 times a third is 30 thirds, y plus 1. Let's just stay on the left for a second. 30 divided by 2, that cancels. That's what we want to have happen. So 30 over 2 is 15y. 30 over 3 is 10 times y plus 1. So look, all of our fractions are gone on the left-hand side. That's awesome. And then on the right, I multiply the 30 into the y over 5. So 30y over 5 plus 30 times 6. Well, 30 over 5 is 6. So that's 6y plus 180. All right, and so now we have an equivalent equation, but it's nicer on the left and it's nicer on the right. Right, so it's the same way of saying, if something on the left is equal to $10 and something on the right is equal to $10, and we have some process that inflates them both by, by whatever, 30. By the balance principle, $300 is the same as $300. So this is still a true sentence, just like this is. Even though it looks very different, it means the same thing, and the same values of y will make it true, and that's important. So now you can go through and solve this, as you would. 15y plus 10y plus 10 equals 6y plus 180, and then go about isolating y and solving for it using the principles of 1.5. Okay, so there are some that are of this form. There's another one that tricks a lot of people because I believe it has some implied brackets. something like this. X plus 4 over 10 equals x minus 5 over 7. It's the same principle that you want to have happen here. You've got some stuff equals some stuff. It's not as nice, so how do we get to nicer stuff? What would we multiply by? Well, we need something that will cancel with 10 and something that will cancel with 7. One guaranteed way to get that nicer multiplier is 10 times 7, which is 70. So if I blast both sides by 70 over 1, we'll see the 7 and the 70 and the 10, sorry, cancel. So 70 over 10 times x plus 4 equals 70 over 7 times x minus 5. And so 70 over 10 becomes much nicer. It's just 7 times x plus 4. 70 over 7 becomes 10. And then from here, same thing. Distribute to ungroup. And then solve for x without fractions, because now you've got some nicer stuff to work with. Okay, so the big thing you need to do is just make sure that you identify the denominator for all the fractions. That defines what you're going to inflate both sides by. And then once you do that, all of them should cancel out. If they don't, that means something went wrong and you need to try again. Okay, so have fun.